So let's do another example. And this example is like a composite function of a composite function. So we can see that we have e raised to something. So we have like an inside and an outside function, but then that inside function is also a composite function. And so we're gonna have to do like kind of this double chain rule sort of thing. And so what we're gonna do is we're gonna work outward, inward. So we're gonna say our outermost function is e to the something, and then our inside function, u, is equal to cosine of 3x squared plus 5. And then the derivative of my outside, this is just e to the variable. The derivative of that is just e to the variable. And then the derivative of my inside, well, we have to do the chain rule on this to get the derivative of my inside. So what I'm going to do, what I like to do is I like to do kind of a sub problem, a sub chain rule problem to get the derivative. So I'm going to say for this specifically, my outside function again here is cosine of u. My inside function is 3x squared plus 5. The derivative of my outside, the derivative of cosine, is negative sine of u, and then the derivative of my inside is equal to 6x. And then now the derivative of this is, we apply the chain rule. So it's the derivative of my outside evaluated at the inside. So this is going to be negative sine of my inside, 3x squared plus 5, times the derivative of my inside times 6x. Okay, so all of this was kind of like a sub problem to get the derivative of my inside for the bigger problem. And so let's kind of erase this because it was just kind of scratch work or like a sub problem. And then now that we have the derivative of my inside, I can use it to find the derivative of my like whole big function. So then my whole big function, we're going to do, the derivative of my outside evaluated at the inside. So this is going to be e to the cosine of 3x squared plus 5 times the derivative of my inside. So times all of this. So times negative sine of 3x squared plus 5 times 6x. And that's it.